In this video, I wanted to show you guys how you can factor polynomials by synthetic division. We didn't do this in class because we didn't have time, but it's kind of a useful technique, and it's a way that you can actually use your calculator to help you figure out the factorization of a polynomial. But basically, returning back to our concept on division, remember that when we divide polynomials, we can tell whether or not they're divisible by synthetic division. And I kind of want to draw some parallels between numbers here, because factoring polynomials is very similar to factoring numbers. Like, say, for example, I'm looking at just the number 40, just to pick a number at random off the top of my head, 40. That could factor as 10 times 4. But another way to draw factoring trees, which is used in a lot of other cultures, is if you have 40, you could always divide out a factor such as 10, which would leave you with a factor of 4. And you could kind of continue dividing the factor and figure out the prime factorization of the number by breaking it down as such. Now, usually as it's factored, only prime factors are being factored out in each component. So like, for example, 2 could be factored out first, which would leave me with 20. Then from 20, I could factor out 2 again, which would leave me with 10. And it's kind of like you could keep factoring out the prime factors until we don't have anything left. And we could find the prime factorization by using all the numbers on the outside. And the reason I bring it up this way is because this is sort of similar to how we can use synthetic division to find the factorization of a polynomial. Because when you're using synthetic division, you're dividing out factors in the same way and checking for divisibility. If you find a factor which is divisible, then you will be able to find the result as well. But let's look at an example. Let's solve it using the magic X method first, and then I'll kind of show you how you could have used synthetic division instead. So like in this one, if we were to build a magic X, we would put negative 77 on top, negative 4 on bottom, and this should be 11 times 7, which would leave us with negative 11 and 7, which would leave us with the factorization x minus 11 and x plus 7 as the answer here. And I didn't need to do the whole splitting and grouping technique that I was talking about in the last video because there is no leading coefficient, or technically there always is, but it's 1 in this, in this particular case. So how could we have used synthetic division? But my point here is that if I'm factoring a polynomial into 2 parts, that's equivalent to, say, taking the entire polynomial and dividing by one of those. So like another way we could have thought about this is if I take the original polynomial and put it in a synthetic division bar, let's say I was to divide out x minus 11. Remember, if I'm going to divide by x minus 11, that would just be equivalent to putting 11 here. I could check to see if x minus 11 is a factor via synthetic division. So it's sort of an elaboration on guess and check, but you could always use synthetic division to see if a polynomial is divisible. And notice what I would get is whenever I get a remainder of 0, what that tells me is that x minus 11 was a factor of the polynomial, but also x plus 7 is a factor as well. And this is kind of my point in terms of how you can use synthetic division to factor polynomials. We can use synthetic division and the fact that we get a 0 remainder to actually progress through this. And there's actually a polynomial theorem, which is sometimes called the remainder theorem or the factor theorem, which proves that whenever we get a 0 remainder, that always correlates to the x-intercept of a particular polynomial graph. And this is actually another approach to using your calculator to help with factorizing polynomials, which basically, if you graph the polynomial and look for the x-intercepts, those will always correlate to the factors. And instead of having to guess, like, because notice the only way I was able to do this here was because I already knew how it factored. But let's say I'm looking at this one, I'm not sure what the answer is. I could always begin with my graphing calculator, and I could type in my polynomial, x squared plus 18x minus 40. And I'll go ahead and zoom standard so it's in a more normal graphing window. And I could look for look for the factors of the polynomial. Like in this case, notice the polynomial appears to cross the x-axis at 2. And basically, that's correlated to the 0 of 2, which should actually correspond to the factor of x minus 2. And this is getting into a little bit more, some polynomial theorems that are actually not a part of our class. But basically, what you want to do is divide out. I'm going to kind of skip the y because I actually, we get into this a lot more in pre-calc. Instead, it's not really part of our class, but I just wanted to show you how you do it. But basically, if I synthetically divide out by x minus 2, you would always keep the same sign here as the 0. Basically, this will work. And there's a simple, well, maybe not simple, there is a mathematical reason why, but it's a kind of a cool shortcut which can help you factor polynomials if you get stuck. But basically, let's just check out to see that this will work. So if I drop 1, multiply 2, this would give me 20. 2 times 20 is 40. Add 0. And notice it is divisible. Again, and if I get something which is divisible, it implies that the original polynomial was factorable. So again, kind of translating this to what did I just do? Well, I divided by x minus 2. So I know x minus 2 is a factor of this because it was divisible. And also, let me get rid of all that. Also, what I got at the answer was x plus 20, because that's my quotient. And so, sort of like I was saying before, if I started with a polynomial, I get a remainder of 0. That implies that the other two components multiply back together to get the polynomial. Just like over here when I was talking about factoring, right? 40 is comprised of all of these things multiplied together, while x squared plus 18x minus 40 is comprised of x minus 2 and x plus 20. And notice that makes perfect sense here, right? That answer, if we follow it out, x squared plus 20 minus 2 is 18x minus 40. Cool, awesome. So what does this mean? If you're ever stuck, or if you want to try to use your calculator to help, basically you could always start by looking for the x-intercepts and dividing those out by synthetic division. Like in the next case, let's just do one more. 2x squared plus 7x plus 3. And notice that it appears to cross at -3 and 1/2. But I would always try to take ones that are whole, but you can use synthetic division with fractions as well. But it's always a little bit harder to see on the graph if it crosses at a particular fraction. But again, so what I want to do here is synthetically divide out by the -3. And I'm going to put my polynomial in there. So if I drop 2, that would give me -6. Add 1, -3, 0. Again, and if you're not getting 0 when you're doing synthetic division, that just means, okay, this is not working that way. And so, you could always revert back to the magic X or whatever other method you want. I just wanted to give you more tools, more ways. And there's a lot more methods of figuring it out as well. But the more, the merrier. Anyways, so what that leaves me with is, of course, x plus 3, because that's what I divided by. And what I got from my answer was 2x plus 1, the quotient. Because remember, this is always representative of dividing by x minus this, which, when you're subtracting a negative, results in plus 3. And then the answer to my division problem is at the bottom, 2x plus 1. Cool.